Okay, we are live. Ooh. Hey guys, so we are live and we are in a new setup as you can see. And tomorrow I have my exam of okay, you can't read it, so it's thermodynamics laboratory manual, and tomorrow is my exam. Fuck those graphs. Okay, you have one night to prepare for all of them. So I think we should get to work. Okay, so let me lay some ground rules for you. So these are not like ground rules, but the things that I know from exams that have occurred before me. So from where I study, we are divided into batches, and each batch has a separate time for their exam. And my batch is a later one, so tomorrow is my exam. Today we are also lab exams, and the thing is, we do not have to do the entire experiment. We will be given the results. We just have to do the calculations. Yeah, simple as that. And yeah, the new setup. You guys like it? In the last video, in the last stream, I told you we'll go on a new setup, and yeah. So I have set this up on my 3D printer. You guys, I don't think you guys can see it properly, but yeah. Let me show you. Try to show you. Oh. So this is my 3D printer, and I'm just sticking you on my 3D printer. Oh wait, these are some strong magnets. And yeah. Okay. Yeah. So from what I know from my exam is, let me sit. Yeah. So from what I know from the exams that have occurred is, wait. A1 कैसा रहा? परफॉर्म कुछ नहीं करना है. They will give observations. We just have to do calculations for our expressions और basic theory रट लेना. बहुत मजा आया. And whatever detail में पढ़ के जाना है. Okay. So yeah, as I told you, we just have to do the calculations. Nothing else. So yeah, and theory. Yeah, theory is important. Calculations. So, in short, no fun part of doing the experiments. You have to do the manual labor of calculations and theory. I think theory is important, but calculations, come on man. It's 2025. AI can do that for me. Okay. So study of thermodynamic properties using steam table and Molière diagram. the scheme table for experiment 1, and yeah, we have to go through the theory as well. Okay guys, so I have the steam table with me. I have acquired the steam table. Um, so let's read the theory. Yeah. Objective: to study thermodynamic properties of steam using steam tables and the Mollier diagram, and apply them to practical engineering systems such as turbines, boilers, and condensers. Additional computation and validation may be performed using engineering equation solver (EES). And okay, theory: it is well established that a pure substance has a fixed chemical composition throughout, and its famous examples are water, nitrogen, helium, carbon dioxide. Also, it is clear that these substances may exist in different states like solid, liquid, gas. There are many examples wherein two phases of a pure substance coexist in equilibrium. For instance, water exists as a mixture of liquid and vapor in the boiler and the condenser of a steam power plant. There are two main states in liquid basis, because it is well known that the temperature at which water starts boiling depends. It is well known that the temperature at which water starts boiling depends on the pressure, and that at a fixed pressure the boiling temperature is invariant. When the vaporization process is through, if any heat loss will result in condensation of the vapor in liquid, and then furthermore, the amount of energy that is required for changing the phase of a substance is called latent heat, specifically the amount of energy absorbed. Oh, frick.
How much do you like it, man?
Guys, let's show some love. Um, okay. So we have this diagram. This is important. Let me draw it for you guys. Yeah. Not the best handwriting or drawing in the world. Bear with me. Is this visible? I don't think so. Yeah, let me draw a bigger one. Yeah, great. This is visible. Liquid saturated. This is V. This is temperature, volume. Okay. I think we should skip the first one for now. Lot of pain in the ass. Temperature calibration of a temperature bath using a standard digital temperature indicator. Standard temperature. Okay. So this is an experiment. I know. So yeah, let's do this one first. And actually, I remember performing it. It's quite easy. I think I should share this video to my friends. Sure, why not? Okay. So, to calibrate the temperature bath by comparing with a standard reference instrument, to analyze zeros, follow procedure and evaluate instrument performance using data. Introduction. Temperature calibration is a critical procedure in metrology and instrumentation to ensure accurate temperature measurement. A temperature bath is used as a stable temperature source for calibrating thermometer sensor for temperature indicators. The calibration process involves using a standard digital temperature indicator SDTI. Okay, so what we need. Standard digital temperature indicator as a reference, comparing its readings with those of temperature bath under key calibration conditions. Okay. Did you guys know that temperature changes due to vibrations? These are atomic vibrations. These atomic vibrations happen due to which temperature rises, and this is due to the atoms vibrating, which causes kinetic motions, and that kinetic motion is converted into heat. Crazy. We got heat. Okay. The calibration aims to determine whether the temperature bath meets its claimed accuracy or if corrections are needed. The error is calculated as wait, experiment procedure. Pre-calibration checks ensure that the temperature bath is free from any physical damage. Ensure. Okay. Switch on calibration procedure. Okay. I do not require that. What I require is set temperature, the temperature reading, digital B, set temperature, temperature reading in bath A, bath B, the difference, and error percentage. Yeah, that's it probably. Define temperature calibration and explain its significance in why it is important to allow temperature to stabilize before record readings. I think third, the accuracy ratio after okay, I think experiment 2 is done. There is nothing to do more over here. So moving on to experiment 3. So first one we have skipped, second one is done. I think I should make a checklist. Yeah, so I'll just make a rough checklist with all my used graphs which officer did not approve. I'll say no more. Tomorrow is my exam. Do not want to get in trouble during my exam. Fuck no. Okay, so this is a checklist till 9. 10th one I could not fit. I'll add it over here. I think this is good. Oh fuck. Not 8. 10. Okay, so first in your checklist, there's a tick in 2. Let's go. Okay, so now moving on to experiment 3. Ha ha ha. Determination of steam dryness fraction using separating and throttling calorimeter. Uh, let me see. Yeah. Damn, this is pretty significant. Okay, I'm going to sit for I think 2 minutes to read all this. You guys can sit as well and read it with me. Read it with me. Sorry, my English is bad, very bad. Mini boiler pressure P1. Steam inlet pressure at separating calorimeter P2. Steam pressure at throttling calorimeter or pressure of steam at throttling P4. Steam pressure at separating calorimeter or pressure of steam before throttling P3. To determine the dryness fraction of wet steam using a combined separating throttling calorimeters and to analyze the thermodynamic properties of steam using pressure and temperature. Fair enough. If any of you guys come, please drop a message in the YouTube chat. Okay, so I have been reading this and I do not understand what's going on. I think I need help of YouTube. That's right, YouTube. So I'm going to watch a YouTube video right now. In you guys will watch me watching a YouTube video on YouTube. This is fun.
ये ड्राइनेज फ्रैक्शन ऑफ स्टीम होता क्या है, क्यों इसे हमें जानना या इसका डिस्कशन करना जरूरी है, आखिर हम लोग कैसे किसी स्टीम को हम लोग समझ सकते हैं कि
हेलो स्टूडेंट्स, प्रॉपर्टीज ऑफ स्टीम में आज एक और इम्पोर्टेंट क्वेश्चन हम पढ़ने वाले हैं जो कि 3 से 4 मार्क्स में बहुत बार पूछा जाता है. सो आई होप यू आर रेडी विथ योर पेन एंड पेपर. सो विदाउट वेस्टिंग मच टाइम लेट अस स्टार्ट दिस वीडियो. तो क्वेश्चन है, एक्सप्लेन द टर्म्स ड्राइनेज फ्रैक्शन, वेटनेस फ्रैक्शन, स्पेसिफिक वॉल्यूम एंड इंटरनल एनर्जी. यानी ये जो चार टर्म्स है, ड्राइनेज फ्रैक्शन, वेटनेस फ्रैक्शन, स्पेसिफिक वॉल्यूम और इंटरनल एनर्जी, उन्हें हमें डिफाइन करना है स्टीम के रेफरेंस में. तो सबसे पहले स्टीम क्या है वो देख लेते हैं. तो स्टीम हमने पिछले वीडियो में देखा था कि स्टीम एक ऐसी चीज होती है जिसमें वाटर पार्टिकल्स होते हैं और वेपर पार्टिकल्स होते हैं. अब हमारे पास कोई एक स्टीम है तो वो स्टीम के अंदर कितने वाटर पार्टिकल्स हैं और कितने वेपर पार्टिकल्स हैं वो अगर हमें जानना है तो हमें स्टीम का ड्राइनेज फ्रैक्शन निकालना पड़ेगा. ड्राइनेज फ्रैक्शन क्या हो गया? ड्राइनेज फ्रैक्शन एक ऐसी टर्म हो गई जो हमें स्टीम के अंदर कितने वेपर पार्टिकल है और कितने वाटर पार्टिकल है वो हमें बता देता है. तो वही चीज यहाँ लिखी है. ड्राइनेज फ्रैक्शन एक्स होता है. इट इंडिकेट्स हाउ मच अमाउंट ऑफ वाटर पार्टिकल्स एंड हाउ मच अमाउंट ऑफ लिक्विड पार्टिकल्स प्रेजेंट इन अ गिवन स्टीम. ठीक है. एज फॉर एग्जांपल अगर हम बोले कि कोई स्टीम का ड्राइनेज फ्रैक्शन हमारे पास है कुछ 80%, तो इसका क्या मतलब निकलेगा कि स्टीम के अंदर 80% वाटर पार्टिकल्स है. क्या है? एंथैल्पी. इसका
Hello everyone. So now let's look at the dryness fraction equations. Okay, these equations are namely something like that. Uh, this they are only used when your state, right, where your steam is at, is under the so-called hill, okay, which is when it is in a wet steam. Okay, you will have a certain dryness fraction of your steam. So for example, if your steam happens to be on the left-hand side of the hill, you'll be along the F line, okay, the saturated liquid line. Or if your state is over here at the right side, you're at the saturated dry steam line, okay, you're at the G line. So when you're at the F line, you actually just started to boil. You have not converted any liquid into gas yet. So the dryness fraction, right, the level of dryness is still considered zero. It's still zero. But things are going to change. The liquid is going to slowly convert to gas, and that's where your state is going to slowly right. It gets drier and drier because more liquid is converted to gas. So the dryness fraction is going to increase all the way until the end here, where everything is converted to gas. The dryness fraction is now equal to 1. Okay? So dryness fraction ranges between 0 to 1 within the wet steam region.
Hello students, welcome to my channel. In this video we are going to discuss example 2.2 from chapter number 2, the working fluid from the book Applied Thermodynamics by Please. The statement of example is calculate the dryness fraction, specific volume at the specific internal energy of steam at 7 bar and specific enthalpy is 2600 kilojoule per kilogram. So first of all, we will write the given data. We have given the pressure 7 bar and enthalpy, specific enthalpy is 2600 kilojoule per kilogram. So
So guys, a little update. I've been trying to learn this dryness fraction thing on YouTube. No progress. Literally no progress. All the videos are shit. Literally. I guess I have to upload the videos now once I learn this concept. Probably I'll do that. Surely I'll do that. Okay. So now it's time to get help from AI. The stream's going great. Very entertaining. I'm so entertained. My balls are in my mouth. Fuck me. Oh yeah. Bro. Guys, I got the Gemini 3 Pro. I'm such a big fan of this AI and all. I love it. Do you want me to do something entertaining? I don't think so. I'll do it because tomorrow is my exam. Literally, quite literally. And I have to study. And bro, this thinking model is taking forever to answer. Trying, man. So now I'm calling my friend for data. हेलो एक्सपेरिमेंट 3 માં ઓબ્ઝર્વેશન ટેબલ મોકલને અને કેલ્ક્યુલેશન બી ફટોફટ The job is done. My friend will send me the data. I'll learn it. Use the steam tables to find the enthalpies. You need HF, HFG at pressure P3 and enthalpy. How do I find all surprisingly, I cannot believe that the stream is going so smooth. Yes. Lol. Come on, AI, give me my answer. But this thinking model is ball slow. You recorded 0.99 and 0.93, etc. હેલો.
શું છે ફાઇનલ?
શું કહે છે? શેનું ફાઇનલ?
આનું પેલા છે.
અરે આ વાળું જ કરીએ ને.
એના માટે રોજ કરી દઉં કે તું કરે છે?
હવે તો નહીં થાય મારાથી પ્રિન્ટ. મારા ભાભી ઊંઘી ગયા. તારે જ કરવું પડશે.
બધું કાલે જ આપવું જરૂરી છે?
તો બીજે ક્યારે આપી શકીએ આપણે?
પછી તો આપણે જવાનું આવશે કોઈ વસ્તુ માટે મંડે પહેલા.
મંડે નથી સર, મંડેની ફ્લાઇટ છે એમની.
ચાલ.
હા.
હેલો.
હા.
હા તો કાલે આપવું પડશે.
હા.
સારું કરું કઈ નહીં.
હા.
At 7 bar, we have, if we check the steam table of wet vapors or saturated vapors, so at 7 bar we have Hg value which is specific in 30 and saturated vapor line, and its value is 2764 kilojoule per kilogram. HF is 697 kilojoule per kilogram. Specific
Calculator and section specific value.
vapor line is 0.27.
Okay. I get a little bit. operating calorimeter and throttling calorimeter.
According to textbook, throttling calorimeter, a throttling calorimeter
Is Separating and throttling calorimeter experiment.
According to romus.edu.iq, throttling and separating calorimeters are used to measure the dryness fraction of steam. If the steam is sufficiently
Shut the
dry, the liquid can
fuck
reach
up.
a supersaturated state by throttling process.
It has been 10 minutes. We've been boiling for 10 minutes at 100 degrees Celsius here. And it is time to transfer this hot metal into that cold water. So loosen this.
I think that's it for today. I'll study off camera and complete the syllabus tonight, and we'll do a stream tomorrow. Yeah, we'll do a stream tomorrow. Peace, guys. Bye bye. Have a great night. Sleep tight.